Hello, folks, and welcome to this webinar where we'll be talking about GitOps with Ant Miell. Hi, Ant, how are you?
I'm good. How are you?
I'm great, thank you. So, Jan, you're a software consultant, actually a partner at Container Solutions, and you're also an author. And I even saw you being called an IT historian somewhere on the nets.
I wonder, was that, that would have been related to my recent piece on using an LLM to write a history essay, because I was a history graduate. So yes, someone may have decided to call me that.
Wonderful. Okay, so yeah, we'll probably hear a little bit about GitOps history today. And with that, let's start talking about GitOps.
Okay, thank you very much. So today we'll be talking about who's afraid of GitOps. So firstly, let me talk a little bit about my experience with GitOps, because that might help frame the discussion today. And if you have any questions, I think you have ways of passing them through. We're very interested in your questions on the subject. So I worked in GitOps projects in banks from 2017. So in 2017, the phrase GitOps, or the word GitOps, was defined by Weaveworks, who were also based in London with me. And so I knew the guy who wrote the original article, Alexis, and we discussed it, and it turned out we were already doing it at the time. And so I've worked on it since then. I moved on to another bank, and then I became a consultant, and I work now for a cloud native consultancy whose bread and butter is doing GitOps platform implementations. During the pandemic, I wrote a book on GitOps, which was quite fun to write while in lockdown. And I've also written books on Docker, Git, Terraform, and Bash, which is my favorite technology because I'm old. I also blog on GitOps and other tech subjects. So I blog on zwischenzugs.com, and I also blog for my employer at Container Solutions. In case you're wondering, Zwischenzugs is a chess word. I play chess, and it means in between move. So it's kind of the stuff I do in between work. So that's why it's that odd name.
Yeah.
Okay.
By the way, it doesn't matter how old you are, you still can't really do DevOps or platform without Bash.
That's right. This is the argument I make. It's everywhere, so people should learn it formally, but they don't. They just muddle through. But that's another webinar. Okay, so GitOps in one slide. So for those people who don't know about what GitOps is, or are unsure or whatever, this is an attempt to describe it in one slide, but we'll go into each point in depth. So there's basically 3 points, 3 principles that underlie GitOps. You can argue there are 4, but I basically prefer to use the 3. One is the declarative system operation. So using declarative languages such as YAML to define your platform, your infrastructure, the software you're running. That your deployment artifacts and your deployments are source controlled. So that's the Git part, clearly. And versioned and immutable. So anyone who's used containers knows what immutable is. You build your container or your package or your artifact, and it has a tag on it or a SHA, which identifies it uniquely. So you can always say this thing is running here, and this is what it is. And finally, and this is the one that people often miss off when they're talking about GitOps, is the continuous reconciliation. So there has to be something that makes sure that the system you're targeting stays in the right state. Okay, so those are the three parts. So bear those in mind as we go through today. Okay.
By the way, just a small note, we're currently running a poll for the folks who are watching us on Zoom about your stage of GitOps adoption. So we would like to know if you're already doing GitOps in production, or only in staging or dev or testing, or maybe just planning, or maybe still debating if it's worth going there. So if you're LinkedIn Live, please submit your answers there.
And yes, very interested in that. It helps me tailor the discussion. It helps us tailor the discussion. So I put this. Sorry.
So why GitOps?
Yeah, why GitOps? So I put this picture here. It's there's a famous TV show. The American version is the most famous, The Office. But being British, I look at the British version. And the manager character in the British version of The Office is asked, "Where's your processes? Where's the documentation?" And he says, "It's all up here." And this kind of encapsulates what GitOps is trying to fight. So it solves different anti-patterns that we've seen. Now, if you've ever worked in typically in a bank or a financial services institution, one that's very concerned about security, you will likely have seen in infrastructure a spreadsheet that manages the firewall. So there'll be a spreadsheet, and every time someone wants to make a change in the firewall, they'll raise a ServiceNow request or some sort of process tool like that. And the request will eventually be approved and then go to a network engineer. The network engineer will open up maybe an Excel spreadsheet, now in the cloud probably, but traditionally in a shared drive, and they will manually adjust the spreadsheet, and then they'll manually go and change the firewall, and then they will manually close the spreadsheet, and then everyone is happy. Now these kind of manual processes cost money in the end. In the short term, not so much, because in the short term, you get the job done pretty quickly. There's no problem. Everything looks fine. But in the long term, it causes great problems, because what you end up with is a system that goes out of, well, first of all, you have a system where you can't be sure that the Excel spreadsheet or whatever it is matches the desired state. And you can't be sure, because everything's done by hand and things can get missed or changed or lost. You don't know exactly what's going on. So this is a step forward from it's all in my head, it's all up here, but it's still not a great place to be. And GitOps seeks to address this. And the other main anti-pattern is deployment by hand, which many of us, I guess people are going into the industry now and they may never see deployment by hand. It used to be the norm, and it used to be even normal when I joined the industry in 2000, around the year 2000. Even source control was argued against by some of the older engineers that I worked with. So none of these things can be taken for granted, but gradually the industry is moving towards this way of working. So as I mentioned, you have this uncertain desired state because you don't know exactly how the system should be configured. And then you have the uncertainty about what state the system is. If you imagine the firewall, you can't look at the spreadsheet and be sure that everything is closed that should be closed and everything is open that should be open. But you'd have to go and check by hand. And then, of course, if you don't know either of these, there's going to be some sort of gap between the desired and the actual state. And then you have control challenges. So if an auditor comes along and says, is your firewall in the right state? You say, well, we have this spreadsheet, and say, okay, but how is the spreadsheet maintained? Well, someone goes in and does it by hand. Okay, no, we have to go and check the firewall by hand to be sure it's in the right state, and then maybe check all your change requests. So there's these challenges around, and they're very important for regulated environments. And this is where GitOps really shines, of knowing what state your system is in, should be in, and being sure of that. So GitOps solves these challenges in three main ways. So firstly, it defines the state of the system declaratively. So I'm sure many people listening, I'm pretty sure Anton has written code in Python or maybe Perl or something like that in the past that manages systems in a programmatic way. So may go onto a system, determine whether the code is there, then install the code if it's not there, and then make decisions and so on. And these procedural configuration languages, or just programming languages, are a recipe for confusion, doubt, uncertainty, bugs, and so on. So GitOps first demands that the state of your system should be declared rather than programmed. Okay. So if you've ever used YAML, if you've ever used JSON, you'll be familiar with what declarative means. It means you can't jump around the flow of execution. And then if you define your system using templates, then you can overlay different environments configuration on top. So customize, for example, allows you to do that. So declarative is one part of the solution. The second is that it's source controlled, versioned, and immutable. And we've already touched on this, but just to repeat, the system state, those declarative text files that define the state of the system, should be in source control, should be managed in a versioned source control. Git is so ubiquitous that it's even in the name, but you don't have to use Git. You could use Mercurial, you could use any source control system, as long as it has versioning and the ability to reproducibly recreate the state of a code base at any given time. Now, application software can't be written declaratively. It does have to be procedural. So that doesn't really change, but you place them in containers, which can be considered a packaging tool. And that packaging tool is versioned and not ever changed once created. So what this gives you is the ability to say, we know exactly what is the state of a given system at a time by inspecting the declarative definition of the system, plus the state of the packages, the artifacts that have been deployed to that system. And you can look at this as an extension of the everything is code movement, which was very popular about 10 years ago. And finally, and this is the one that people miss when they're discussing GitOps initially, is the idea of continuous reconciliation. So if you've ever used Chef or Puppet or Ansible in an iterative way, then these are tools which are designed to help you reconcile the state of the system with your definition. And the diagram here, which is the very abstract description of what a controller does in engineering, not in software engineering, in engineering in general. But software engineering has borrowed this concept and applied it to the GitOps area, particularly in Kubernetes. So a controller, classic example of a controller is the thermostat, which has a desired state, where the dial is. It has an actual state, which is what your temperature is, and a detection process. So the detection process figures out the difference and decides what to do based on it, and then goes and measures again, compares, goes through the process, and so on. So these three things are together what make up a GitOps system. So if you think about your deployed code, if someone goes on and changes the version of a package on there, then the controller, in this case, the continuous reconciler, will replace that package that you've updated with the desired version, not the defined version, not the one that you've just changed. So if you've ever been used to going onto a system and just manually changing some config on a few servers and then going home because everything's fixed. That's not the way it works anymore. So what does this add up to? We end up, as a result of these three principles, we end up improving reliability because, well, for two reasons. And the reason is at the bottom. Because you have a system that builds artifacts and is defined in code, you have the ability to take any release and spin up an environment that matches any other environment and run some tests. So this capability allows you to be much surer of releases. And so anyone who's done continuous integration and or continuous delivery will know about this benefit, but it's an intrinsic part of GitOps. If you're doing GitOps, this ability to test your artifacts, test your code, falls out as a natural consequence. And so because the system is in a state you know about, you can then become more comfortable with your automation, and then reliability improves. It's also more secure because you can shut people off from a system and not let them log on to change things by hand. And it's particularly in highly regulated environments, that's a great thing because you can just have a break glass procedure. In the event of an extreme emergency, someone can go onto the system and inspect it if they need to for support purposes. But generally speaking, no one has access. And that improves massively auditability, because you can say, oh, we only let people on at these times. We watch what they did, and we know that they didn't. We know exactly the steps they took. We have a recording, say, of what they did. In addition, in terms of auditability, you have an audit history of who changed what code when. And because of that audit history, you can then catch bad actors within your system more easily. So it's another level of auditability, which is very good for managing operating systems. Ultimately, you get lower cost of ownership. You get less time spent debugging because you're more sure that it works. And also, and this benefit hasn't come up so much in discussions around it, but you can bypass some of the horrible old processes in ServiceNow, enterprise ServiceNow systems, and replace them with a more lean Git process. You can't get rid of things like ServiceNow. They're probably not going to be thrown away, but you can at least manage those processes using just source control.
Can I challenge you on that?
Oh yeah, sure. Please do.
This has improved productivity. So I don't know about ServiceNow, but in my mind, it's much easier to run a command and change the system than it is to go edit some code, submit a pull request, wait for it to get approved, and only then see it applied to the actual system. It
is, yes. So this is, I mean, we'll get onto this later, but for sure, I miss those days because you solve your problems quickly and in one's mind as an engineer, quite cheaply. I would say that the long-term benefit is far greater because as an organization, not as an individual, as an organization, you can be sure of the state of things, which means you can make organizationally different decisions and ultimately move much faster getting features out. So this is one of the motivators for a lot of people that I work with, is they can't make changes because they're not sure of the state of that customer's installation versus that customer's installation. So a deployment takes 2 weeks for this customer, takes a week and a half for that customer, takes a month for that other customer because they had some crazy difference in their configuration compared to other people. and as a result, you get this sort of confusion. And I think it's important to note, when I do projects at home, I still I still develop in production when I'm running stuff on my own at home. I don't have a full GitOps procedure at home, but obviously when I'm with customers and there's hundreds of people working on a code base, yeah, it's a different story. You have to go a bit slower.
So basically, the same benefit as with a centralized source control system. So it's you give up on some individual productivity in order to achieve collective productivity benefits.
That's a really good analogy because it's one I remember. So yeah, when I started in the industry, my mentor, who was like 20 years older than me, said he didn't bother with source control because there were only 2 people in his team. So he had tar files, he had scripts, and he said, "I don't need source control. I know what I'm doing." But there are still cases of teams who don't use source control, but they're pretty rare now. And I think GitOps is a similar thing. It will just become the standard way of working.
Okay, makes sense.
Okay, so GitOps tooling. I lifted this diagram from the book I wrote. So I put this together when I was writing the book on GitOps, and basically it's kind of a history. So maybe I'm an IT historian. It's kind of a history, a family tree of technologies that have led to GitOps, and you can see the 3 strands that I talked about, the 3 principles in there. So one is, for example, declarative on the left. In the middle, you have source control. And on the right, you have continuous reconciliation tools. So at the top, we have running commands by hand, which was the original, the second generation of computing was how things were done once we had terminals. Then we had the shell script, which was batch file, which was the compilation of these into a unit of work. And then next we had make, which was a declarative way of defining how the state of the system should be. It allowed you to manage the state declaratively instead of programmatically. And in the middle you had RCS, CVS, SVN, Mercurial, and ultimately Git in 2005. Oh, it's nearly 20 years old. It's interesting. And these kind of merged with descendants of Jenkins and tools like Jenkins and TeamCity into tools like GitLab CI/CD and GitHub Actions. And then you put all these things together and you end up at the bottom level with Kubernetes-based tools, such as Kubernetes itself, which I omitted from this diagram, but it probably should be there at the bottom. And then tools like FluxCD, which was 2016, ArgoCD, which is 2018, and Jenkins X, which is a whole suite of packages designed to allow people to build GitOps. So these things are not new. These ideas are not new. They've just been pulled together and given a name, which allows people to understand what it is. And unlike DevOps, it's very opinionated. So people still argue about what DevOps is and is not, just like they argue about Agile. But GitOps has a definition. There is an actual definition you can go and look up, and it's by the people who coined the term. So there's much less religion about it. And that's another advantage for the industry, that there is a kind of shared understanding of what it is and what the tools within it should do.
And there's now also an open GitOps initiative.
Oh, yes.
Trying to define a standard.
Yeah. So, as time goes on, it's going to become more solidified. And there's no such thing with DevOps, right? There was no authority, which is in keeping with the kind of, agile attitude. But yeah, GitOps is a lot more prescriptive and opinionated, yeah.
Yeah,
So
and we have another poll running right now on Zoom, but if you're on LinkedIn Live, feel free to answer too. So we're asking what GitOps tool you're currently using, and the choice is between ArgoCD, of course, Flux, Fleet by Rancher, if anybody is using that, or nothing yet.
yes, that would also be interesting. So yes, so GitOps tooling. Well, Kubernetes is the big lighthouse project for this, and it's the place which has made controllers famous, if you like, in the software world. So Kubernetes is if you don't know, Kubernetes is a cluster of systems which run containers for you, so containerized applications. And configuration is done through YAML or JSON, and everywhere within Kubernetes there are control loops. So it's constantly looking at the system and deciding, are there too many of these objects in the cluster, or there are too few objects in the cluster? Should we create those? Should we auto scale? These are all run by controllers rather than programs. So behind the scenes, there is a program that has logic in it, but you don't see that. You just define what you want, and then the system takes care of getting it into the right state. And that's a key aspect of GitOps, that you have this principle of declarative definition, and then something goes and does the hard work for you of figuring out how it's done. And those things are commoditized. So they're in containers typically, and you can download them, and the logic is there, and it's maintained by someone who's responsible for it, and you know which version you're running, and so on. And so that also increases reliability because the system's behavior is predictable. Okay, another big tool within GitOps is Terraform. So this defines the infrastructure as code. It uses a declarative language, HCL in this case, which is HashiCorp's invention. Obviously, it's as code friendly, so it's source code friendly. Famously, there is an open source version of Terraform that allows you to define your infrastructure declaratively. And there is a rival tool called Pulumi, which always comes up in conversation, but more in conversation than in my experience in use, which is allows you to write your code non-declaratively, but then it in a way compiles it down to a declarative a way of working. I wrote about this a while ago, so I'm not going to go into detail on it, but I had fun trying to figure out exactly what the line is between declarative and procedural. But yeah, Terraform's definitely declarative minded tool. And finally, in state reconciliation, this is the newest area that GitOps deals with. We have pull and push tools. So we've seen some of these mentioned in the slides. Pull tools sit on the system, interrogate the system, and compare that to the definition in source, and then make changes. Push tools sit on where the source control, typically where the source control is managed, and push changes out to the system, to the target system. And they can also read the state of the system and decide what to do about it. But gradually pull tools are taking over, in my experience, in the industry.
Yeah, actually, if we look at the open GitOps standards, the fourth point that you've omitted says based on pull. So, yeah, basically, that's what it's saying.
Yeah, and I'm not sure it's a separate. I don't think it matters. This is kind of a religious discussion, but I don't think it matters how the state is maintained as long as it's continuous and it compares on both sides. But I have to say that pull tools are more naturally able to go both ways because they sit in the system, so they have permissions within the system to look around, and then they have a tunnel back to the source to look at what the situation should be. Whereas push tools generally don't have quite as much power to run the system remotely, to interrogate the system remotely and change the system remotely. But I have a spot for it because I'm old and I used Customize and GitLab CI/CD quite a lot when building GitOps.
Yeah, this reminds me of the push versus pull discussion in monitoring tools. You know, when Prometheus first arrived, they said push it isn't more scalable. This is wrong. Pull is more scalable. So.
Yeah, it is a very, I mean, I think we end up having the same arguments in software that we've been having in business and engineering for hundreds of years. But push and pull, definitely, I think edge triggered and what's the other one? Edge triggered and something else triggered was the other one I remember in software.
Yeah, tabs versus spaces.
Yeah, tabs versus spaces. Yeah, well, we all know which is right there, don't we? Okay, so the last kind of, or another area that's significant with GitOps is secrets. So many people, when they hear about GitOps, they sort of say, well, how do you deal with secrets? Because you can't have secrets in your source code. That's madness. So you have various choices at that point. One is to type them in by hand manually, which is the kind of traditional way, or put them on a piece of paper and leave it around the office. But more seriously, recently, there are tools like HashiCorp Vault, which are very generic secret solutions, which allow other systems to interact with that sort of safe, that's secure place of secrets, and Kubernetes can also interact with it as well. So that's one option. There are other industrial options for banks and so on, which are very, to take the security of those secrets to a very high level. But most people we work with don't use HashiCorp Vault. They use what we call the external secrets operator, which we wrote in combination with GoDaddy, which essentially sits again on your it's a controller that sits on your system, and when it sees a reference to a secret, it will then, based on a YAML definition that you give it, go and collect that secret from the store, whether it's AWS secrets, whether it's Azure secrets, or whether it's HashiCorp Vault, or whatever other system has been integrated. I think there's over a dozen of systems that external secrets operator connects with. So eventually someone has to put the secret into the secret store, or you can have them automatically generated by a system user. But those secrets sit on an external system, and your reference to them is defined declaratively, not the actual secret itself.
So maybe this is a good point to ask. There is a question coming from LinkedIn Live from Wagas Ahmed, who says, what's the best approach to secure secret manager client ID and client secrets? How can we secure them?
So this question is asking, as I understand it, about securing the client ID and client secrets. Well, we've talked about secrets and how they can be secured, because in Kubernetes, secrets are not actually encrypted. They're just base 64 encoded. But if you're talking about the connection between so when you're initially setting up a Kubernetes cluster with your applications, someone has to give the credentials to the operator that it can go and get those secrets. Mm-hmm. There's many ways to do that, and they follow the same pattern as the one I talked about before. So someone could go and type them in as an administrator onto the Kubernetes cluster, or you can have them auto-generated in Terraform and stored in a secret store in Terraform, and no one necessarily has to see them. The difference between these two approaches, these two extreme approaches, by hand or fully automatically, is the amount of engineering you might have to do to tie everything together and make it work. So there's many good patterns on that, but usually we've found that it's a kind of bespoke solution every time, because no one has exactly the same configuration of tools, the same configuration of environments, and so on, and the same security policies. So there's usually a lot of work to make that work together. But the best approach, is a no one sees the secret. It's automatically generated by a service account, not by a user. It's placed in a secret store that is only break glass access to the owner of the account, or the billing account, and so on. So the level to which you want to go with the security angle of GitOps really depends on your cost appetite and your risk appetite, and that's a judgment for every team.
Okay, sounds fair.
Thank you. So where I work, we wanted to come up with a catchy kind of name for our most common deployments. So we call it the Kate stack, which consists of Kubernetes, ArgoCD, Terraform, and external secrets operator. And we find that for many of our customers, certainly not all of them, but many of them follow this pattern, and it's becoming a pattern that's used by a lot of people who don't necessarily want to use an IDP, and want to still have some sort of control over their deployment process themselves. And these tools are becoming solidified in the market, I would say. But it's not a stack that we own in any sense. It's literally a name we can give it so that we can know what we're talking about. A bit like the LAMP stack. I was going for something like that, if anyone remembers the LAMP stack.
So if, for example, I want to switch out Terraform and replace it with Crossplane, this will be a Cake stack, right?
Yes. So yeah, Cake was another option that we could have gone with. So Crossplane, yeah, it's a good point. Crossplane is an emerging player in the market, and we've done some projects with Crossplane, and I would say that first of all, it's because of partly because of the adoption isn't so widespread yet with Crossplane. It can be harder for people to pick up. So usually it's picked up by someone very motivated, very talented engineers really like it. There is a learning curve. There's definitely a learning curve about compositions and how you define things and how you deploy your systems with Crossplane. But if anyone doesn't know, Crossplane is a tool that allows you to define, and it uses the Kubernetes etc.d database, but it allows you to define collections of infrastructure items together as a single object within Kubernetes. So, for example, you could say, I want a LAMP stack, and it creates one LAMP stack in your Kubernetes cluster. So you see one LAMP stack, and then behind the scenes, it goes off, it creates a Linux machine, it installs Apache, it installs MySQL, it configures MySQL, and what was the P in LAMP stack? I'm trying to remember.
PHP.
Yeah, it installs PHP. I was thinking Perl, but it can't be Perl. Yeah, PHP. Installs PHP and gives you a development environment for you, for example. Now, if you wanted to do that before, you might have to create all these things separately and glue them together. Or in Terraform, it's quite difficult to, well, if not impossible, to do that so easily. So Crossplane is, as teams go further in their GitOps journey, they start to ask themselves these questions. Like, I don't just want to create a Kubernetes cluster or a deployment of my application. I want to go and create things outside the system as well. I want to use this control plane across more systems. The other point about Crossplane that we've observed is that upgrades can be very tricky. So if you have a changing definition of your object, this doesn't seem to be a solved problem yet, exactly how you upgrade your old objects to new objects, which to me sounds like the old database problem. You know, if you change the schema of your database, how do your apps get upgraded without some sort of outage? Well, you have to write some sort of upgrade code, and it can get very messy very quickly. But yeah, it's the same problems in a different form. But yeah, crossplane is definitely becoming more popular.
Okay, and you get the added benefit of defining everything as YAML.
Yes, which everyone loves. So a lot of people get frustrated with YAML because it's well, I don't get frustrated so much with Kubernetes because I'm very used to the idea of declaring what I want and Kubernetes sorting it out. But certainly with Terraform, there are many times when I really wanted to drop to some procedural language like Python and just say, like, if this has been created, then go and create this other thing. So yeah, people can get very frustrated with YAML, and then also you get systems like GitLab CI/CD where it says it's declarative, but actually it's somewhat procedural, and you can even embed procedural concepts within your CI/CD code. So yeah, I mentioned I wrote a piece on this. I did write a piece on this, and the closer you look at this distinction between declarative and procedural, the less clear the distinction becomes. But that's probably a question for another day.
Okay.
Okay. So lastly, I've told you about all the benefits, and in the long term, everyone makes a profit. So why is everyone not doing it already? Okay. So I've got a little diagram there from Professor Heath Robinson, who was an illustrator who had Professor Brainstorm as his character, and Professor Brainstorm came up with these crazy machines which were really complicated to do very simple things. And this is one of the challenges of GitOps, right? So I'm going to start with the business challenges. The real business challenge with GitOps is you can't just install GitOps and move on with your day. It requires changes potentially across your business. It's very like doing DevOps. You can't just install DevOps. You have to actually change your mindset. And the same is true of GitOps for many businesses. And if companies want to invest in this, they will not see a return for potentially quite some time. So we worked with a client and we had a very successful engagement with them, and they got going with a platform. And 2.5 years later, they finally decided, yes, we're going to do everything this way from now on. So it's a long journey for them to figure it out. And that's not unusual. So making it clear to the business that it's going to be a long time before you see the benefit, potentially. But then once you've got the benefit, you cannot go back. Once you can stamp out environments immediately, and you can test things quickly, and you can deploy things really quickly and be sure that it works, people love it. Business loves it. But yes, it is work to get there. There's a cultural challenge. So if you work in an environment where people love to dive onto servers and fix things and look like heroes, then they're going to have to learn to slow down, like Anton, slow down and not just fix something quickly and move on with your day. They've got to actually, be good corporate citizens and make sure they do it right. And that can be a challenge for a lot of people who simply don't want to work that way. And then finally, technical. So there are many environments where people just don't want to be concerned with all this YAML. They don't want to be YAML engineers. They don't want to necessarily want to work with Kubernetes. They don't care about how things get provisioned. And again, this is like DevOps, because there were developers who didn't want to do ops, and that was their life, and they were quite happy with it. But there were other people who wanted to do more stuff. So those challenges together amount to a lot of change for a business potentially. So in order to challenge these challenges, you have to approach it in that 3-pronged way. So one rule of thumb I give clients is, you're going to spend 50% on the technical side and 50% on the outreach, on the socialization of these technologies. because IT companies tend to think of things in terms of delivering the software, but actually delivering the mindset change is a much harder thing to do and requires what we call missionary work. We call it missionary work in our company, but it's basically like you go and build the thing and then you have to go and preach the good word and actually sit with teams and show them how it can be better and get over the skepticism that they might have. And you also have to train people about these new technologies and so on. But the other prong, so there's technical, cultural, but there's also explaining to business in a way that they can understand. This is the benefit you'll see. This is when you'll see it. Don't expect it to be too quick. But when once you get there, then you can start to change other things like your business, like running software as a service becomes much easier with a GitOps approach.
You call it missionary work. I call it drug dealing.
Well, that's what consultants do.
Yeah, exactly. But not only consultants, it was the same when I was working inside an organization, implementing new processes and tools, and then getting folks to use them.
Yeah, it's
you give the first sample free, and then when they're hooked, they come asking for more.
Yes, and that's how we got people onto GitOps at a bank I worked for. It took them 6 weeks to provision a VM in their virtual environment, but they could get onboarded within a day to our Kubernetes cluster and start spinning up pods. And yes, it was free in development. And then there's a whole question of chargeback and accounting for these things. But that's, again, another topic for another day, but it's one I enjoy.
Okay, so evidently, I have a question about the human side of GitOps in the way who do you see updating the infrastructure definitions, the deployment definitions, the YAMLs, the Helm charts? Are these for the ops folks to manage, or do you see developers changing them? So
that is a great question, and it's one that I get asked a lot by clients who are interested in doing it. So the answer varies. In your more tech savvy organizations, your hedge funds, your tech savvy organizations, it's a combination of a centralized team and the engineers. And one of the benefits, actually, I was talking to a client the other day, and they said one of the great benefits about Crossplane was that it effectively open sourced their control plane. They had a platform built in 2014 or something that was basically their control plane, but users couldn't get behind the curtain. But now they can. They can make changes, and they're bought in to Crossplane. So they're building a Crossplane solution to kind of augment their existing control plane, which is 10 years old, and those business units can now make changes. So in those organizations, you get that approach. But generally, it tends towards the center, in my experience. And generally, there are exceptions, but generally, most of the clients we work with still depend on a centralized team for the expertise, for the change process, for all those things. With a few, there's usually a few ambitious people who get involved.
Okay, so thank you for this answer. And there's also another question from LinkedIn Live coming from David. What is the best way to run a smoke test as soon as a deployment is completed in a GitOps approach? For example, triggering an AI third-party tool every time a new deployment has succeeded.
It's a rule of webinars. You have to mention AI at some point. Actually, I worked with David on one of the projects I mentioned before, so I know him well, and he's asking a very tricky question. I mean, I don't really have a strong view on this. You could set up a trigger within your Kubernetes deployment that when it changes, you have a controller, which when a deployment changes, you can then run a automated smoke test. I haven't seen many testing tools use AI in live situations, so that would be really cutting edge for me. Yeah, but most people that we work with run smoke tests within non-production environments, and then if it goes to production, if they're not doing 100 releases a day, with 1,000 developers, which is not typical. If they're small enough, they will still do smoke tests by hand just to check that it worked and what changed and so on. But yeah, I don't really have a strong view of that in GitOps. I don't think there is a kind of GitOps smoke test tool out there.
Yeah, well, maybe there's something to ask from my side, because I'm talking about progressive delivery at KubeCon next week. And both of the major GitOps controller tools, ArgoCD and FluxCD, they have a complementary progressive delivery controller for them. So Flux has Flagger and ArgoCD has Argo rollouts. How widely popular is that? How much do you see your customers, for example, complementing their GitOps solution with a progressive delivery controller? Because that could also be used for, smoke testing whatever gets deployed to the cluster.
Yeah, I haven't. Most of our customers don't use Flagger. So first of all, most of our customers use ArgoCD, and I think it's mainly because of the GUI. I think that's a big reason it won out. I used Flux in 2019, and I really liked it because it was command line, and I'm a command line person, and I really enjoyed that aspect of it. But it's hard to beat ArgoCD's UI in a demo, especially if you're showing it to someone who's non-technical, because the ability to see all those things. I mean, there is a UI for Flux, but it didn't really take off, and it wasn't part of the core product. So yeah, first of all, it's ArgoCD, and then Flagger. I don't think we've ever seen anyone use Flagger for progressive delivery. Perhaps that's more to do with the nature of our clients. I think it's really, Flagger would be great in an environment where you have like a big retail company and many releases, hundreds of releases a day potentially. Then you start to need these tools. But I don't think we've worked with a client in that area or with that profile.
Okay. Thank you. Do you have any more slides, or is the final?
Yes, I think that's the last slide.
Okay. Thank you for that, Jan. I think do we have another question? Okay. Christopher is asking, how about using K6 with pipeline?
I don't know what K6 is.
Yeah, I know. K6 is a load testing, an open source load testing tool from Grafana. That's it's part of the cloud native ecosystem, and it's becoming quite popular now. We're also using it at perfect scale.
Okay, so what's your answer?
Possible. Again, I think the question here is, how do you hook to that? And the possibilities there are, again, using some kind of a progressive delivery controller, or maybe using Helm hooks. So if you're using Helm has post hooks and also has test hooks. So you could connect that to your K6 testing, whatever. Again, I don't know. I think we're not doing enough load testing in general in this era of, readily available resources. But now that we're in a bit of a market downturn, maybe we'll become more cost and resource aware, and this topic becomes more interesting and relevant now.
I think so too, yeah.
Okay, so thanks for that. Thanks. I think we've learned a lot. I personally learned a lot. It's always great to hear from someone who was there from the start and who's there, to hear from a consultant who's seen a lot of these GitOps deployments. And this is also a place to say that next month we're having another webinar talking about WebAssembly, WASM, with Sayam Pathak of Sivo. And of course, next week we'll see many of you, our listeners, at KubeCon, hopefully. Perfect Scale will be there at booth C31, I think we said it is. And Jan will also be there in the crowd. So this is your chance to find him, remember his face now, and catch him in the crowd, ask him about GitOps.
Yeah, I look forward to that. Please do.
Thanks, Jan. A lot of fun talking to you.
Me too. Thank you.
Bye.
Bye-bye.